How it goes. All right, well, welcome to the Unit 3 webinar. Today we're going to first talk about, we're going to go through the outline. We're going to go through some of the activities, talk about additional resources just to remind you that they're there and give you some time to work, whatever time is left at the end. And we'll turn off the camera for that time to work time so that I can help you or you guys can communicate with each other during that piece. The first thing I want to do is go into the Unit 3 organizer, and it's sort of scroll down to the bottom. So if you don't know where that is or you don't have that open, I'm going to go ahead and drop that link in the chat. So let me go ahead and pull that up. My Zoom link, so here we go. And I'm going to put that in the chat for you guys. So if you guys wanted to follow along by looking at that, you certainly could. And later on when I talk about references, I'll show you where to get that if you have forgotten where to get these things from. So this is the Unit Distance Planner, and it comes with its student interactive notebook. And when you click on that link, that'll open the notebook that sort of looks like this. Just a tip along those lines, both I have found in my classroom and with my colleagues, as well as some of the other folks who have worked on this, but when we've talked about it, is breaking those interactive notebooks up into task sets seems to work a little bit better for some of the students because some of them have difficulty loading the entire interactive notebook on some of the Chromebooks. Some people are fine with it being one big piece and want it that way, but a lot of people want it broken up. You can offer it both ways, or you can offer it just broken up if you find that that's more useful for you. Okay, so let me just go through sort of the outline of what's going on, and then I'll probably give you a brief overview of what each activity is, and then I'm going to talk about what I would put on synchronous and asynchronous days and kind of what my unit planner looks like. And then we'll go from there. And then we'll go into show you where these things are to get to from the PMSP website. So this first activity, so I'm just going to talk through them first, and then I'll go back and show them to you just to make sure that you're oriented to the unit. So the first activity is the unit opener, and we've got a couple different versions of the unit opener here. One of them is a slideshow that's about 20 minutes with 2 short embedded videos to kind of generate questions about nuclear technology and whether or not we should use it. The second optional opener is a flash debate that runs about the same distance of time, where students have what I call an internet debate, where they don't use any resources or information. They just go with their gut and come to the conclusion that they can't come to a conclusion with just their gut. And then they bring out all of the questions that they would want to answer with this unit, and then we align them with the unit. So I'll show you both of those in a minute. After that, and those pieces are more likely to want to be a synchronous lesson because you'll have people kind of talking to each other. The next thing is the where do elements come from. So this is watching some videos and doing some articles about stellar nucleosynthesis, so the formation of elements in stars. And so it lends itself really well to an asynchronous activity because they're kind of watching a video, they're maybe doing some avid text marking, or they're writing up a summary of one of the articles. And so that seems to lend itself well to asynchronous work. The next task set is looking at band of stability practice problems. And these practice problems I have found tend to be a little confusing the first time they see them, but once they get the hang of them, they do fine. So I recommend starting this on an asynchronous day, or if you're going to start it on starting this on a synchronous day. If you're going to start this on an asynchronous day, I recommend maybe a short 20-minute, maybe small group meeting where you can explain it to them and then give them time to do it. I would do it on a synchronous day for that reason. After that, there's a piece around radiation. And so it starts off with how a nuclear power plant works, lets them go through a sort where they look at different kinds of radiation. Then they play with this simulation called Marie Curie's lab. And in that Marie Curie's lab simulation, they see nuclear decay happening, and they can trace the decay steps from uranium that we use in a nuclear power plant to when it finally decays to lead. I recommend at least starting this as a synchronous activity. And then once you've got them started, they can finish it as an asynchronous activity because it seems to take a little longer than one class period. The next lesson is task set 5. Is nuclear waste safe? And this is talking about how long does it stay safe? So the half-life lessons. And when we did this in live, we would do this either with flipping discs or with rolling dice. And so this is an automated simulation that they play with the R code to do a dice simulator to see what happens with the half-life. Depending on your students' familiarity with code and how well you think they would be able to do that, you can decide whether you want them to make changes to the code or whether you want to make changes to the code as a demonstration and then have them talk about the half-life pieces afterwards. And then last, there is a flash, you can either a flash debate where you put people in small rooms to talk about nuclear technology, whether it's good or bad. Also in previous years, I've done sort of a larger group discussion where we talk about the Hanford Nuclear Reservation in Washington and what are the pros and cons of that. So there are some different possibilities you can do around a debate. This would have to be a synchronous class because you're having students communicate with each other. There's an alternate lesson if you want to get into it around how old is the Earth. It involves watching a video and kind of reading an article. So this lends itself well to an asynchronous class with maybe a follow-up of a synchronous, like a short discussion when you get back together again. And then there is the unit test. And at the end of this, I'll show you, once we've gone through the activities, where to find that test bank again, so that you guys can have some help making those tests or looking at some ideas around questions, because I've seen some instances in doing this webinar before where people weren't aware where some of those test bank questions were to help them out with that. Okay, so that's the general overview. Are there any questions before I move back into kind of talking more in depth about each one of those activities? Okay, I'm seeing lots of no's, so I'm going to move on to kind of going into this. So for this first activity, I'm going to go ahead and show you some of the slides that go through and just kind of describe what that looks like. So there are two. The first opener that is, depending on where your students are at, sometimes you know your students better than I do. So there's this one where it talks about different kinds of like radiation and where nuclear sites are located. And then you can kind of have them make a HKWL board, like I've heard, I know I want to learn on a Jamboard. And then you use those questions to drive the questions of the unit. So there's that activity that you can do. If your students need to be a little bit more rowdy, I tend to do this one, which is the basically nuclear waste. If the question around this is we introduce nuclear waste and where it's located, and then we introduce this ridiculous scenario where PGE is going to buy the house across the street from you, and they're going to buy that whole block across the street from you. You're going to pay them extra money, guarantee them a job, and we're going to bury nuclear waste across the street from your house. So we divide the class into people who are going to get all the money and people who are like, yeah, take my house and pay me a bunch of money, and people who are like, wait, no, I want to live here. I don't want to live next to nuclear waste. And that's kind of how we split them up. Then we give them a few minutes to kind of be in one breakout room. Are you for or against this idea? Give them a few things to think about. And then we give them a few minutes to actually have groups of people talk about to each other in small groups and in breakout rooms to state their case. So each side gets a few minutes to state their case. And the end conclusion is always that no one really wins this debate, and that we need to actually have information to make these decisions. And generally the kinds of things that people come up with as questions tend to be things like, how long does the waste stay bad? So that's that half-life discussion. What is bad about nuclear waste? What are the problems with it? Which tends to be that discussion about radiation and what causes it. As well as like, where does this nuclear waste even come from? And that leads us back into all of the units that we've talked about already. So that's that sort of flash debate idea. Okay, going back to our unit planner, the next item is this piece. I'm not really going to go into depth on that because it's really just sort of playing this video and watching this. There are some teacher notes that kind of guide you through that. These band of stability practice problems, I'm just going to show you sort of what that looks like so you can kind of see that it's looking at this band of stability and looking at the protons, neutrons, and electrons of these different items and then asking some questions about it. So your students may need a little help to maybe do one or two of these understanding this graph. I have found that people at first don't quite get it and then let them kind of work on how to answer these questions, and you can guide them through that if you want to, or you can decide that they can do it in breakout rooms, whatever works best for your students. After that, there is this nuclear reactions piece. I'm not going to go through the slides, but I'm going to show you the two main parts of this. So the first part is you have them go into this spreadsheet. And the idea behind this spreadsheet, the way it's introduced, is we took some uranium and then we let it decay until it turned into lead, until it stopped doing anything, which I know would take a long time, but we're not gonna talk about that just yet. And so each time that it decays, we'd say what the starting atom is, what the ending atom is, and what did we observe. So these are the what did we observe. And the idea is we want them in that interactive notebook to group things together and notice that certain ones cause cell damage. Certain ones cause only damage if you breathe it in, and certain ones cause tumor growth, and or you can, or certain ones are stopped by lead, certain ones are stopped by paper, certain ones are stopped by smoke. And in that interactive notebook, they're going to be ranking those together. So you want to kind of do this synchronous so they can have that conversation. You're going to have them rank those together in terms of which ones go together. And then later in the slides, you give them the science name and tell them exactly what's going on. So they get a little experience of trying to rank it themselves, and then you give them the science background behind that. Afterwards, they go into this Mary Curie's lab. Now, when you open up Mary Curie's lab, it starts off looking like this. And there's a video that you can have them play that kind of introduces what's going on. If you skip that video, there's a help video at the top for CK12 that helps you understand what's going on, but I'm going to go ahead and show you what's going on. So if I wanted to do uranium 235, I first take my protons till I get to uranium, and then I alter my mass by looking at my neutrons until I get to 235. That's generally often one of the ones that they use in a nuclear power plant. And then when you hit the play button, it'll show them like, what did I start with? And see how this is a lot shakier, so it's more unstable. I get to something that's not stable, but more stable, and something else. And then it tells you what those particles are and tells you what kind of decay that is. And so students are going to go through this, and I recommend going through the first one or two with them. And they're going to be recording that in their interactive notebook. So like, here is what it looks like, here is what is happening with the words, here is what, and you can have them say, okay, if I go back into that, what I might say for the word model might be uranium goes to thorium plus heat plus semi alpha, right? Or I could use these symbols to go through there and explain what happens, okay? And then once you've got through one decay cycle, you then take this atom and you start it for your next decay cycle. And that's they get confused on that first part of what to write down, and they get confused about how to do the next one. So I take this atom that I made, the 23190, and I will go make that 90, and then I change this till I get to 231, and then I hit the play button, and that's the next round that I'm going to do. And I'm going to see that it makes a slightly more stable atom, which is here, and then it's going to make my beta and my gamma radiation. So that's what you're doing in this activity. Okay. After we go through those, they're gonna write a conclusion basically saying, is the stuff left over from a nuclear power plant still, is it safe? Do you feel like it's going to be safe right away? And so that hopefully they'll get to the idea that no, the uranium decays into something else that's still radioactive, that decays into something else that's still radioactive, and it keeps going for a long time of making other things that are still radioactive. So that's what the goal is for that. All right, so the next thing is, is it safe, and how long before it becomes safe? And that's this the half-life lab. So I'm going to show you the half-life lab. Here's the half-life lab template. It looks familiar, but when we get down to here, you're going to get to a site, and it's going to have you make these changes to the code. And all the changes to the code are highlighted in yellow, and I'll show you what those look like. And there's also, if you forget how to do that, there's a little video that a screencastify that's in the teacher notes that you can watch again for how to go through this. So in the unit planner, there's a link here to the dice simulator. So I would, if I'm going to have my students do it, I would drop that link in the chat for them. If I was going to do it as a simulation, I wouldn't. That leads to this page right here. And I'm just going to, and this is it's written in R. And so, and there's pretty decent documentation. But like I said, if your students are a little bit overwhelmed by this idea, then you can go ahead and do the simulation for them and show them. And I'm going to do that for you now. Now, the first thing it tells you the notes is to go down here to the bottom and just make a change. There's a typo in this code that you need to fix. And that's the first thing that they're going to do. And that involves just putting a parentheses here and a parentheses here. They left off a set of parentheses. And then just verifying that your code works at all. So I'm going to hit the evaluate button. And there it goes. It tells me, here are all my roles. And there's all my code. These are all my answers. Now, this is way too much data. So I'm going to make some changes now to show you what I'm talking about. So we'd like to have more dice to start off with. So this initial population, that's how many dice am I rolling? So I'm going to change that to 100. This decay constant, this is basically like the probability that when I'm rolling my dice, I'm going to hit a 1. So this would be like rolling a 10-sided dice. And if I had, and when we do to plutonium, you're going to change it to 0.2. That's like rolling a 20-sided dice or a 30-sided die. So for iodine, we do 0.1, and we're going to leave that at 0.1. That's what it says in the instructions. And because this is so much data, we're going to add a line into this code. And I'm going to hit it right here. I'm going to show you right on that half-life template. So we made this change here so that it says this. We made the change on line 2 to say that it's 100. And then we made the change here to verify that that was 0.1. And this is the code that I would have them add. This is going to cut the data down so that we're only getting every fifth thing. And once you put that in, you're going to have to give it a couple spaces here. You'll know it looks good when that turns pink. So that is telling us that basically I'm going to take every roll and I'm going to divide the number by 5. And if it's greater than 3, I'm going to show it. So it's going to show me the 4th roll, the 9th roll, the 14th roll, the 19th roll, and so on. I'll show you what that looks like when that evaluates. And there is the data. So you're going to have your students copy down the rolls, and you're going to have copy down the number that remain. If you get stuck and you're like, okay, I'm not really sure what this all should look like, in the teacher notes is the full code copied out from the site, that if you just copied and pasted this into the site, and I just verified it yesterday, that it will just work. So that you can check their code if you want to have them do the coding. Or like I said, if you're going to do it, you can just explain it while you make the changes and then hit the evaluate button and have them get the data. When you want to, that's going to give us the data for iodine, and we're going to tell people that this is how many days that we get to. So we want to have like a half-life here. Starting at 100, we're looking at a half-life of a few days, not very many days. And they should be able to, it's not going to hit right on that half-life, but they should be able to see where that is, because iodine has a half-life of a few days. So we try to make the simulation match the real world in some manner or another. Now, when you switch it over to plutonium, the only changes that you're going to make is you're going to wind up changing my probability, because plutonium decays a lot slower. So this becomes 0.02. And once again, I don't want a million lines of code. So I'm going to change this so that I'm going to get every 20th row. So basically, I take whatever my roll number is, I divide it by 20 if the number is greater than 18. So that's going to give me my 19th roll, my 39th roll, my 59th roll. I'll show you what that looks like right now. And there's the data that you would have them plot for that. So you can just show them this and then kind of talk to them about it, or you can have them do it themselves. They can, if you have them do it themselves, you can have them play around with what happens if I change my probability. What happens if I change some of the code a little bit more. And what you want to see with that is that basically this probability of it decaying is directly related to my decay constant. So if I have a 1/6 probability, then my decay constant is that K value is related to 1/6. So that's kind of where that's coming from. It's just a piece that's on there. All right, sorry. So then the next activity is the flash debate. And if they have a writing assignment that goes with that. So there's some teacher notes that kind of talk about the flash debate process that you can read through when you're actually doing it. I find that like knowing it ahead of time and then doesn't 100% get me there. I need to read back through it again when I do it. So basically, they're going to gather evidence for a little bit. Then you're going to have a pro and a con group, and then you're going to give them 5 to 10 minutes to kind of all the pro people get together for 10 minutes, all the con people get together for 10 minutes, and then you make a breakout room of mixed pro and con people so that they can have their debate. So I find that when doing breakout rooms, if I assign them the pro and con group and I put them in the pro and con group, I then go through and rename all my pro people to begin with a P, all my con people to begin with a C, so that when I get to the second breakout room where they're actually having the debate, it's easy for me to see, have I put together enough pros and cons in the same room so they can actually have a discussion without getting together. And then we come back into the larger group and talk about how that went. And then they get a chance to write up. I usually have them do the debate in the live session and have them do their write up in the asynchronous session. After that, there is this, how old is the Earth? This is basically watching a video and kind of reading the article. So I would recommend just kind of doing that. It's an optional idea if you feel like you want to put in there as an asynchronous day. And then the test. So for the test, before I get into the resources to help you with the test, are there any questions about anything we've gone through so far? Okay. All those links for all those things were in the unit planner, just so that you know, or in one or in a sublink. So finally, I want to make sure that I know that you sign up for things through the Portland Metro STEM Center site, but not everybody seems to remember, because there was a lot of information you got at once when you originally took classes, that if you come into the site and you click on these 3 lines, you get this part over here that talks about for educators, and you can come into the high school science, and that gets you into the curriculum sites. So if I scroll down here, you can get into the high school patterns curriculum. You can click here for the distance learning resources if you want, but I first want to go into the patterns curriculum because that's where I know the link is. And so in the patterns curriculum, there's a restricted access page. And I recommend like going into that restricted access page. If you've taken the class, you have access. They limit it to people who have taken the class that they can verify are teachers. And in there is going to be like all of the keys to things of what are the answers for some of the problem sets. You're also going to get some test bank questions so you can model what a test might look like. So here's the Unit 3 test bank. So all of these process notes and teacher notes are in this folder for you, but many of them are linked into the unit planner, but that test bank one is not often linked, or if it is linked, people aren't quite aware it's there, but that's very useful, I find, in putting together a test for the end of the unit. It gives me lots of ideas, especially if I'm sort of stressed or if I'm trying to think of where is this unit going? How do I want to talk about this to do that beginning with the end in mind backwards design piece?
Can
Okay.
you show me where that link is again?
Yeah, I'm going to go back through. It's just you go to the PDX STEM website,
Right.
and then I'm going to go back to the very beginning of that PDX STEM website, and then you come over here to the part about for educators, and then the high school science. That leads you to here. At the bottom is well, there's the distance resources, but the high school science sequence will put you there. So if we come through here, that gets us down to patterns and into where you can get to that folder. And then after I show you how to get there one more time, I'm also going to drop the link in the chat for you, just to make sure that you both remember how to get there, and then it's just this restricted access page, but also that you can have the link right now in case you want to just sort of play around with it. in the meantime. Okay, so now that I've gone through the unit, I also want to share another resource with you. And that is in some of the past webinars and also when we were teaching the class, there was some discussion about people wanting to know sort of what does it look like asynchronous and synchronous days. And so I kind of put together a preliminary, if you want to look at what a schedule could look like. It doesn't have to be what your schedule looks like, but here is, and I'll drop that link to the chat in a minute. Here is a link of what it could look like for you if you're teaching it, with like some suggestions about some ideas about what would be synchronous and asynchronous. And I sort of built this around what our schedule looks like with synchronous and asynchronous versus where, assuming that I would start this next week, but you don't have to necessarily follow through on that. There's a few places where you can move things around. There's definitely this career videos that you can have them watch, where you can move this career video around if you need to, based on what your asynchronous and synchronous looks like. There was a request in the last webinar to also show my Unit 2 one. So because some people are still doing Unit 2 or have just started Unit 2. So I have that one linked in here as well if you're interested. But I'll go ahead and drop the link to the spreadsheet in the chat so that you guys can have a sense of what that looks like. I'm going to stop sharing for a moment while I do that. All right, are there any other questions or things that I can do to help you out with this particular unit before I get into the turning off the recording and getting into the actual work session part? No? Okay. I'm going to go ahead and turn off the recording so that the part that we